All right, so let's get going on the last part of today's class. So we're going to continue on with our look at confidence intervals, finish out the ability to calculate confidence intervals. We had just seen how to calculate confidence intervals with a single sample t-test for situations in which you have data from one sample of subjects that were measured once, so that single sample t-test design. And again, this would be used, for example, in the real world context. If you were running a monkey sanctuary, you're not interested that your monkeys spend more time with the terry cloth mother. You're interested in how much time do they spend with the terry cloth mother. When you are in the legal system, you are not, and you're on trial, or somebody's on trial for a collision, and an eyewitness gets their memory tainted, gets their memory rewritten by a leading question. You, as a lawyer, as a judge, as that defendant, are not interested that their memory has been changed. You want to know by how much has your memory been changed. By 10 miles an hour, 20 miles an hour, 5 miles an hour? What is the amount of the overestimation? And the same thing in the business world. A lot of times decisions come down to dollars and cents and the bottom line. So if you are looking to implement accuracy punishments for your workers, such as timeout, 10-second timeout periods, you don't want to know that those 10-second timeout periods are more lead to more accuracy. You need to know how much more accuracy. So are you going to have more productive employees in the 10-second timeout condition or the 5-second timeout condition? You need to know how much more accurate are they in that 10-second timeout condition. So all these estimates of how much is what we're going to be finishing off our look at today. And hopefully you've realized that, much like Dorothy on her way to Oz, when we're calculating confidence intervals, this is something that we've been doing all along. So this is something we've been doing while we've been doing t-tests, while we've been doing all these hypothesis tests. So hopefully you'll appreciate the fact that I tried to introduce these concepts one at a time and not really freak out the way that Dorothy should have. But now we're going to take a look and finish off our look at confidence intervals in this final part of today's class. All right, so we're just going to take a really quick overview of confidence intervals just so we can make sure that it's sinking in. And then we're going to go back to SPSS for an independent means confidence interval and then a dependent means confidence interval as well. And we'll be doing those in class. And I'll mention your homework assignment. This is a special homework assignment, not in my lab. This is an Excel homework assignment. All right, so quick overview, of confidence intervals. Once again, the idea of a confidence interval is based on the idea that you don't know where the mean that you have in your experiment came from. You don't know what part of the distribution, comparison distribution, your sample has come from, but you do know that if you make a range, an interval, as wide as the body of the distribution, then whatever percentage is left in the tails, that is the percentage that your interval will not contain the mean. So if you only have 10% in the tails, you have a 10% chance that your sample came from the tails. That's a 10% chance that your estimate is going to miss what you're trying to estimate. So you got a 10% chance of missing it. You got a 90% chance of hitting it. You can be 90% confident that your interval will hit that population mean. And the formula that we're trying to get it down to, this formula right here, comes from the definition of the t-statistic and just a little bit of algebra to get it down to your population mean, what you're trying to estimate, equals your sample mean plus or minus the t-statistic, which determines the size of your tails, multiplied by your estimated standard error. And as we saw, the components of that confidence interval are there on the comparison distribution. So the comparison mean that you're trying to estimate equals your sample mean. That is your point estimate. That is the center of your confidence interval. And then this plus or minus t-statistic multiplied by the estimated standard error. That lets you know how big your interval is, how big your arms are on the positive side, the plus side, and also the negative side, the minus side of your interval. All right, so let's get back to doing some calculations. So we are going to go through two more practice problems. We've already done Harlow's monkey sanctuary study. So I think I duplicated that on this. So let me just fast forward by that. Oh no, I didn't duplicate that. Took care of this before and I second guessed myself. All right, so we've already done Harlow's monkey study. We've already seen that confidence interval calculated. Now let's take a look at the Loftus and Palmer study. So once again, let's say that you are a psychologist that works as an expert, giving expert testimony in the legal system, and you get called in because this situation occurred. And let's say that this eyewitness gave an estimate of 60 miles an hour. And now the judge wants to know how much did she overestimate her response. What was the overestimation in terms of speed because of this loaded question? So that's what we want to know. And it's based again on Loftus and Palmer's data that we're going to make that estimate. So originally we were looking for, is there a difference between these two groups of subjects? Is there a difference between the two ways of asking the question? We found that there is a difference. So now we want to know how much of a difference is there. How much faster are the estimates for the smashed into group? And notice that here, we're not asking for an absolute amount. We're not asking for what are the estimates for the smashed into group. We're asking for a difference. We're asking for how much faster, how much more. What's the difference for the estimates for the smashed into group? And we're going to compute a 95% confidence interval. We're going to compute an 80% confidence interval. And we're going to compute a 99% confidence interval for this as well. All right, so once again, we are going to go back to SPSS. And we're going to be doing an independent means t-test because in this situation, in this experiment, we have two separate groups of subjects. Each of them measured once. So that is an independent means t-test. So that's what we need to do. So in Excel sheet 09C, if you haven't already, please open that. 09C practice, June 12th. We have the data for demo question number 2. So here are the speeds for the smashed into group. Here's the speed for the hit group. I actually, much like that, some of those cooking shows, I prepared this formatted data ahead of time. So directly underneath that is the actual formatted data, the way that it needs to be organized for SPSS. So we're just going to take that and using this clipboard, we are just going to paste that right in there. We are going to paste that right in there. And we have speed. And we have group. So we have the speed estimates, we have which groups they belong to, and we're going to do our independent means t-test because that is the correct t-test to run in this particular situation. So we go to independent samples t-test, test variable is speed, grouping variables is group. We need to define those. So the first one is smashed, and the second one is hit. And if we were just doing a t-test, at this point we would hit OK and we would be off to the races. However, we are doing confidence intervals, so we have to go up here to options. We click on options and it asks us what confidence interval percentage we want. So the question that we were asked us for a 95% confidence interval. So that is, again, the default setting. So we got 95% confidence interval right there. So we can hit continue, and then we're all ready to go. We can hit OK. And SPSS will calculate, and you can see it right there, 95% confidence interval of the difference. So we needed a 90% confidence interval. We needed an 80% confidence interval. So let's go back to Analyze, Compare Means, Independent Samples t-test. Once again, it's nice when you're doing multiple confidence intervals. SPSS will keep that, keep it set up for you. All you need to do is go to options and put in the correct confidence that you want. So this time we want 80%. We put in 80%, we hit continue, We hit OK, and it has now calculated an 80% confidence interval of the difference. We got one more to go because we wanted that 99% confidence interval. So we go back one more time, analyze, compare means, independent samples t-test, go to options, change that 80% confidence interval to a 99% confidence interval, hit continue, hit OK, and now we have our 99% confidence interval of the difference. All right, so pretty quick way to calculate a bunch of confidence intervals, but once again, we now need to do a little bit of work on our own, because SPSS will give you the mean difference, it'll give you the lower bounds and the upper bounds, but we want to get it into this formulation over here, which is the sort of classic center plus or minus the arms formulation. So let's take a look at our confidence intervals here. We'll do the 99% confidence interval of the difference. So we are still in this equal variance as assumed row right there. There's your degrees of freedom. So if you needed to look up the t-statistic, that would tell you what your t-statistic, what degrees of freedom your t-statistic should be, what comparison distribution it should be looked up in. So if you needed to do this piece by piece, there's your degrees of freedom right there. There is your estimated standard error. So this standard error here is 2.59. All right, so that's just showing you the pieces of this, and then your mean difference, is right, back up, is right there. So this mean difference is 6.8 miles an hour. That's the difference between the estimates for the smashed into group and the estimates for the hit group. Notice that's what we were asked for. How much faster were the estimates for the smashed into group? So that sample mean, that mean difference, that 6.8, that is the center of your confidence interval. That's the center point. That is your point estimate. That's your best guess. So if somebody wanted one number only, you would tell them, okay, she overestimated it by 6.8 miles an hour. However, we wanted a confidence interval. So for this confidence interval, we have the confidence interval of the difference. It's exactly what we want. And here we have our upper bound. So our upper bound is 14.06. And our lower bound is minus 0.46. And that minus is going to be important when we interpret this, but it's minus 0.46. So when we put it into this format of plus or minus, we got 6.8 plus or minus, and then we have to figure out what is the length of this interval here, and you can always get it by going the top minus the middle. So if you go upper minus middle, you'll always be able to figure out the length of those arms. So that would be 7.26, I believe, 6.8 plus or minus 7.26 miles an hour. There's your 99% confidence interval. All right, so that's the 99% confidence interval. And again, you can see that SPSS calculates it for you, and we just need to make sure that we put it in that format right there. All right, so how much faster were the estimates for the smashed into group? Okay, so we've already used our logic, we've already used our math. I jumped my slides a little bit. So we've already done these calculations to get your 99% confidence interval. Same calculation, same logic, same sort of steps to get your 95 and 80% confidence intervals. So why would you use confidence intervals in this situation? Or how could they be used in this situation? Well, let's take a look at what would happen in that courtroom setting. So there's your no difference line. This line right here is the point where the person, the eyewitness, changes from overestimating over here to underestimating over here. And if her eyewitness account is right on this line, then that would mean that it made no difference whether she was asked how fast were the cars going when they smashed into each other versus how fast were they going when they hit each other. So that's important, that little no difference line. All right, so let's say that you're the psychologist on the witness stand, and the defense attorney asks you, how much of an overestimation did this eyewitness give? You know, give me one number, give me an estimate, your best guess of how much she overestimated her testimony. And you would say, all right, well, my point estimate, my high precision, low confidence estimate is 6.8 miles an hour. She said 6.8 miles an hour higher than she actually remembered. And then the prosecutor might say, well, I object. You can't just put in a, no confidence point estimate. We need a 95% confidence interval. And you might say, well, all right, there's your 95% confidence interval. So she overestimated it, 6.8 plus or minus 5.35 miles an hour. So she might have overestimated it all the way up to 12.1 miles an hour, or all the way down to 55 miles an hour. So she could estimate it all the way up to 12 miles an hour. You can be 95% confident that her overestimation is somewhere in there. And then the defense attorney comes back and says, I object. We don't need to be 95% confident. We only need to be 80% confident. And you can say, well, all right, there's your 80% confident. So I am 80% confident that she overestimated her testimony, and I'm 80% confident that she overestimated it by 6.8 plus or minus 3.41. So because these confidence intervals do not contain this no difference line, because both of these confidence intervals are in the overestimation, completely in the overestimation section, that means that you can be 95% confident that she overestimated her testimony. You can be 80% confident that she overestimated her testimony as well. Now the judge might step in and say, well, in order for testimony to be entered into the record, we need to be 99% confident. Can you give me a 99% confidence interval? And you, because you took this course, would say, absolutely. There's your 99% confidence interval. That's the one that we calculated down here. So I can be 99% confident that she overestimated it by 6.8 plus or minus 7.26 miles an hour. And notice that this interval contains the possibility that she did not overestimate it. So this is her not overestimating. This is her actually underestimating. This is her overestimating. So you as a psychologist can be 95% sure that she overestimated her testimony. You can be 80% sure that she overestimated her testimony, but you cannot be 99% sure that she overestimated her testimony, because the 99% confidence interval contains no difference in underestimation as well. So based on how the law works, the testimony might not even be entered into or admissible in these proceedings. All right, last one, timeout. So we know from our analysis that the 10-second timeout condition is more accurate than the 5-second timeout condition. And it might be that this research has made its way to the ears of CEOs of powerful companies who want to implement this so that their workers become more accurate. And they want to know not just that they're more accurate in a 10-second timeout condition, but they want to know how much more accurate. What increases in accuracy can they expect? So for this, we're going to go back to our data and we're going to compute confidence intervals. So we're going to compute for how much more accurate were participants in the 10-second timeout condition. We're going to compute a 95%, 80%, and 99% confidence interval. So once again, importantly, notice, they are not asking how accurate are they in the 10-second timeout condition. They're asking how much more. So they're not asking for an amount, they're asking for a difference. So always take a look at what your confidence interval is asking for. We're not asking how accurate are they in the 10-second timeout condition. We're asking how much more accurate are they in the 10-second timeout condition. So we are going to keep that in mind as we go and run our stats. So once again, back to SPSS, and let's get our analyses for this final confidence interval done. All right, so let's clear out that data. Here it goes. And whoops, that's your homework assignment. And we need our timeout data, so that's data question, demo question number 3. So let's just get this into SPSS. So we have 2 scores for each individual. So this is actually already formatted correctly. We just need to copy it and paste it into SPSS. So let's get that done. And then paste that in here. And my human brain forgot. We got 5 seconds and then 10 seconds. All right, so we go to variable view and we can call this sec5 and we can call this sec10. And then we go to analyze, compare means, paired samples t-test, and we still have our old variables in there, so we can just clear those out. And let's put in the 10-second condition as variable number 1, 5-second condition is variable number 2, because I believe it goes variable 1 minus variable 2. So that will give us the increase in accuracy. And then if we were just doing a t-test, this is where we would end it and hit OK. But we're calculating confidence intervals, so we go to options. 95% confidence interval is the default. That's the first one we want. So we hit continue, we hit OK. And we can see that we have calculated a 95% confidence interval of the difference. Let's do that 2 more times. Analyze, compare means, paired samples t-test. We go to options. This time we want an 80% confidence interval. We hit continue, we hit OK. And now we have an 80% confidence interval of the difference. One last time, analyze, compare means, paired samples t-test, go to options. Question asks us for a 99% confidence interval, so we put that in, hit continue, hit OK, and we have our 99% confidence interval of the difference. So you can see, very quick, very easy, painless way to calculate confidence intervals. You just need to identify which test is it coming from, and in order to do your analyses. All right, so back to the analysis. So how much more accurate were the participants in the 10-second timeout condition? We need to take a look at our outputs, and much like we've been doing, use the same logic, use the same math to put it into this format here, this nice plus or minus format that most people find easiest to understand. All right. So we got, well, I have it backwards in the notes. You've done it the correct way if you followed along in class. If you do this mistake here, just reverse the 2. So I'm just going to reverse it mentally here. So we have a mean difference of 7%. All right, so that's a mean difference of minus 7%, because here we're saying that the 5-second timeout condition is 7% less. So I put it in backwards when I made these notes, but that's all right. We now have a lower limit of 2.388. We have an upper limit of 11.612. So those are the numbers that you probably have in your Excel sheet, sorry, your SPSS output. So let's take an analysis and see what we can do with this. So there's your mean difference. There's your upper and lowers. Yours are reversed to these numbers right here. So what do we do with this? Well, your mean difference, that is this part of your confidence interval. That's your best guess. That's your point estimate. That's the center of your interval. So when somebody in that business asks you, well, what kind of accuracy increases can we expect? You can tell them, oh, well, you can expect 7%. They should be 7% more accurate in that 10-second timeout condition. The upper limit for this 95% confidence interval is 11.6. The lower limit, 11.61. The lower limit for this confidence interval is 2.3, and I'll round it, 2.39. So the accuracy, you can be 95% confident that the accuracy increase in the 10-second timeout condition is going to be at least 2.39%, maybe all the way up to 11.6%. That's your range for 95% confidence. We take 11.61%, subtract away the center, that will give us our length of our arms. So that is 4.61, and that is our plus or minus. So we got 7.0 as the center, plus or minus 4.61 as the arms of our interval, and that is your confidence interval, your 95% confidence interval of the increase you can expect in accuracy for that 10-second timeout condition. All right, so we've computed those. So let's see what they all mean. So once again, there is your no difference line. So this line here is where there is no increase in accuracy between the 5-second and the 10-second timeout condition. So let's see why we might want to compute all these different confidence intervals. So you walk into this corporate boardroom, you're giving your presentation, and somebody asks you, well, why don't you tell us how much more accuracy can we expect in that 10-second timeout condition? And you'll say something like, oh, well, my best guess, what the data tells us, is 7%. That's my point estimate, that's my best guess. You can expect 7% accuracy increases for the 10-second timeout condition. If they then say, well, we can't just take a point estimate, we need to have a certain amount of confidence. So one CEO steps up and says, you know what, I got a lot of my money invested in this company. I can't risk this investment unless I'm 95% sure that we're going to see an increase in the accuracy. So you can say, all right, no problem, 95% confidence interval right there. So 95% confidence interval, you can expect 7% plus or minus 4.6% accuracy increases. Another CEO might say, you know what, I don't have as much money tied up in this company and I like to live dangerously, I like to live risky. All I need is 80%. You say, all right, well, there's your 80% confidence interval. You can expect 7% increase. Notice the center of the confidence interval does not change. You can expect a 7% increase plus or minus 2.79%. And so you can expect maybe all the way up to only up to 9.79%, but definitely at least 4.29%. And then we might have one last CEO, and they might say, you know what? I borrowed money from the wrong people, and if this goes south, they're going to break my legs. So I can't be 95% confident. I can't be 80% confident. I got to be really sure about this. I need to be 99% confident. You can say, absolutely, there's your 99% confidence interval. You can expect increases in accuracy up to 13.71%, and you can expect at least 0.29% increases in accuracy. Your accuracy is definitely going to increase. You can be 99% sure about that. So there's an example of the 3 different confidence intervals and how and why those might be used. All right, that was a lot of stats. So we're going to wrap things up right now. So just want to make you aware of the homework assignment number 13. So this is a Excel. This is the final Excel homework assignment. It's available in Excel homework. So download the homework assignment number 13, confidence intervals Excel sheet. You are looking for this one right here. So what you want to do for this, read the descriptions, identify what the correct t-test would be, single sample, independent means, dependent means t-test, and then using that correct t-test, calculate the point estimate, your best guess, a 99% confidence interval for this question. So the confidence intervals will vary from question to question, but this one wants a 99% confidence interval, point estimate plus or minus a certain amount, your the one side of your interval, and an 80% confidence interval. So number one, make sure that you find your homework. It's in the Excel homework folder. Number two, when you're doing your questions, make sure that you are paying attention to what it's asking for. So for example, this one wants to know what is the decrease in the mental rotation ability after stereotype activation. So read whether it's asking for an amount or a difference, and then also read the direction that it's looking for. So if I told you that there was a 9-point decrease, that means that scores went down. If I told you that there was a minus 9% decrease, that means that scores went up by 9, right? So a decrease of minus 9 is 9 in the other direction. So when it's asking for decreases, increases, I'm not going to play, grammar, syntax games with you, but pay attention to what it's actually asking for. And specifically, is it asking for a decrease, like question number 1 is, or is it asking for an amount? So for example, here we have a question, what is the average height of the population for today's 7-year-old students? It's not asking you how much taller are they than they used to be. It's asking what is the height right now. So pay attention to whether it's a difference or an actual amount. And then the last thing to notice is that you do have unlimited attempts to do this, and it will grade itself. So you can scroll below the question and it'll show you what portions you got correct, what portions you have incorrect, and it'll automatically grade your sheet as well. So feel free to do this as many times as it requires to get yourself 100% on it. And then once you're done, upload that to Canvas in the appropriate assignment tab, and you will be done this homework assignment. So that homework assignment is due after the exam. So we have our exam on the 17th. This homework assignment is due the 18th by midnight. So you might actually want to give this one a shot because you have to do t-tests in order to complete this homework. So exam number 3 is all about t-tests. So you can actually use this homework as a little bit of extra practice to make sure that you're on the right track with your t-test. However, it's not actually due until after the exam, so just bear that in mind. June 18th by midnight. And then it was a packed day today. We don't have a lot of time for some in-class practice, but there are a few more questions in those Excel sheets. So if you want to give those a go, if you want to calculate on your own some of the ones that we showed in the follow-along demo, feel free to do that. The demo questions are in the PowerPoint slides that we've been going through. So there's demo question number 4, demo question number 5, as well as the solutions to those demo questions. So if you'd like to do that, feel free. We got about 12 minutes left before the end of class. Otherwise, if you want to call it an early day, feel free to do that as well. And I will just mention that we have, just for today, another class is coming in here directly after our class is done. So bear that in mind, we are going to need everybody to leave at 12:15 to make room for that other class. Other than that, we are done for today.